Hello friends, today we will discuss about the Unit 1 Microprocessor subject, features and architecture of the 386DX and its operating modes. The features of 386, as it is a 32-bit microprocessor, thus has a 32-bit ALU, arithmetic logic unit. A 386 has a data bus of a 32-bit. It holds an address bus of the 32-bit. It supports a physical memory addressability of a 4 GB and a virtual memory addressability of a 64 TB. 80386 supports a variety of the operating clock frequencies, which are 16 MHz, 20 MHz, 25 MHz, and a 33 MHz. It offers three-stage pipelines: fetch, decode, and execute, as it supports simultaneous fetching, decoding, and execution inside the system. Now we'll see a 80386 architecture which is on a board, as it has a 5 basic units: bus interfacing unit, memory management unit, execution unit, instruction decode unit, and code prefetch unit. Now we'll see in detail of each execution, each unit. Bus interfacing unit, as we have already discussed, that 8036 possesses the ability of a three-stage pipelines, thus perform fetching, decoding, and execution simultaneously, along with memory management and bus accessing. Thus, all these units operates parallelly. This pipelining technique leads to a reduction in overall processing time by increasing the performance of the overall system. Now further and understand the operation of each of the unit as details. A bus interfacing unit. The bus interfacing unit, or a BIU, holds a 32-bit bidirectional data bus as well as a 32-bit address bus. Whenever a need for instruction or a data fetch is generated by the system, then the BIU generates a signal according to the priority. For activating the data and address bus in order to fetch the data from the desired addresses. The BIU connects the peripheral devices through the memory unit and also controls the interfacing of external buses with its coprocessor. Second part is a code prefetch unit. This unit fetches the instructions stored in a memory by making the use of a system buses. Whenever the system generates a need for instruction, then the code prefetch unit fetches that instructions from the memory and store it in a 16-byte prefetch queue. So to speed up the operation, this unit fetches the instruction in advance and the queue stores these instructions. The sequence in which the instructions are fetched and get stored in a queue depends on an order they exist in the memory. As this unit fetches one double word in a single access, so it's such a case, it is not necessary that each time only a single instruction will be fetched, as the fetch instruction can be part of the two different instructions. It is to be noted that a code prefetch holds a lower priority than a data transferring, as whenever a need for a data transfer is generated by the system, then immediately the code prefetch loses control over the buses, so that a bus interfacing unit can transfer the required data, but prefetching of a required data. But prefetching of an instruction and storing it in a queue reduces the wait for the upcoming instruction to the almost zero. So the third part is the instruction decode unit. We know that the instruction in the memory are stored in the form of the bits. So this unit decodes the instruction stored in the prefetch queue. Basically, The decoder changes the machine language code into the assembly language and transfer it to the processor for the further execution. The next unit is the execution unit. The decoded instructions are stored in a decoded instruction queue, so these instructions are provided to the execution until in order to execute the instruction, the execution unit controls the execution of the decoded instructions. This unit has a 32-bit ALU that performs the operation over a 32-bit data in a one cycle. Also, it consists of a 8 general purpose registers as well as 8 special purpose registers. These are used for data handling and calculation of offset addresses. Next point is a memory management unit. This unit has two separate units within it. These are segmentation unit and a paging unit. The segmentation unit plays a vital role in a 8036 microprocessor. It offers a protection mechanism in order to protect the code or a data present in a memory from application program. It gives a 4-level protection to the data or a code present in the memory. Every information in a memory is assigned a privilege level from PL0 to PL3. These are the privilege levels. Here, the PL0 holds the highest priority and a PL3 holds a lowest priority. Suppose, one example we'll discuss here, suppose a file is needed to be accessed, stored in a memory at the privilege level 0, that is a PL0. Then only those programs which are working at a PL0 level would be able to access that file, while other programs will not be able to access the same. If a file is present in a PL1, then a program of the PL0 and a PL1 both can access it, as a PL0 has a highest priority than a PL1. So for a protection purposes, the main part of the OS is stored in the PL0 file. A PL3 holds the user program, providing a protection to the data or a code inside the system is the most advantageous factor that was first given by the 8036 processor. A paging unit operates only in a protection mode and it changes the linear address into the physical address as the programmer only provides the virtual address and are not a physical addresses. The segmentation unit controls the actions of the paging unit, as the segmentation unit has the ability to convert the logical address into the linear addresses at the time of the execution of the instruction. Basically, it can change the overall task map into the pages, and each page has the size of the 4K, thus allows the handling of the task in the form of the pages rather than the segment. The paging unit supports multitasking. This is so because a physical memory is not required to hold a whole segment of any task. Despite this, only that part of the segment which is needed to be currently executed must be stored in that memory whose physical address is calculated by the paging unit. This resulting reduces the memory requirement and hence this frees the memory for other tasks. Thus, by this we get effective way for managing the memory to support the multitasking. So we will find out a next point, that is an operating modes of the 386. The 386 supports a 3 operating modes: real, protected, and virtual read mode. We already discussed in our previous article that 80286 supports a 2 operating modes, whereas the 80386 supports a 3 operating modes, that is a real, protected, and a virtual mode. However, we have to be better operating performance. A separate software command is used to switch from a real mode to the protected mode, but it requires the resetting of a microprocessor in order to switch to real mode from a protected mode. This drawback was eliminated in a 3.6 that allows the switching between the two modes using the software command. In a protected mode, the 8036 microprocessor operates in a similar way like the 80286 but offers higher memory addressability. Whereas in a virtual mode, the overall memory of the 386 can be divided into the various virtual machines and all of them acts as a separate computer with the 8088 microprocessor. This mode is also called a virtual 8086 mode or a V86 mode. The other one is the virtual real mode. This mode allows the system to execute a multiple programs in a protected memory and is in case a program at a particular memory gets crashed, then it will not cause any adverse effect on other part of the memory. Thanking you for watching the video.